Hey everybody, welcome to the Digital Analog. Let's get started. Today, I want to answer a common question amongst everybody from old to young. Why do I buy a brand new hard drive that says it's 4 terabytes, for example, and only get 3.63 terabytes out of the box? That's literally the question up here on the screen from on this Best Buy product page. This ranges, of course, as the bigger you get, the more data space seems to be missing off of your hard drive. The common answer that some people put out there is flat wrong, and the respondent to this question actually got close to the right answer, and they did attribute that the common response is wrong as a wrong response. The common response is to say that, oh, the hard drive, when it formats, it takes up some space on the formatting process, and therefore it doesn't have that full capacity. That's baloney. The person here responds and says that the reality is that drive manufacturers consider they count their numbers by thousands, meaning you have 1,000 bytes and that gets you 1 kilobyte, and then you have 1,000 kilobytes and that gets you 1 megabyte, and then you have 1,000 megabytes and that gets you that gets you 1,000 gigabytes, and then you have 1,000 gigabytes and that gets you 1 terabyte, and so on and so forth. Terabytes is the most common we're up to now, so that's where I'm stopping at. When he then says in reality, however, a terabyte is 1,024 gigabytes, and a gigabyte is 1,024 megabytes, and a megabyte is 1,024 kilobytes, and a kilobyte is 1,024 bytes. He's actually wrong on that part, and I'm going to tell you why. And it's not what you might think. The reason is, so a megabyte is indeed megabytes, gigabytes, terabytes, kilobytes, going forward, petabytes and exabytes are indeed factors of 1,000. Now, I don't want to lose you too much in the math, but basically that means every 1,000 you have a new number, just like you have 1,000, and then 1,000,000 is a million, and then 1,000 million is a billion, and then 1,000 billion is a trillion. You have the same situation with bytes as it relates to kilobytes, megabytes, gigabytes, terabytes, and so on. What we're actually seeing here is a product of them using the wrong terminology. What you should be using is this chart here. Megabyte, megabyte, gigabyte. I'm sorry. Megabyte instead of megabyte, gigabyte instead of gigabyte, and terabyte instead of terabyte. Have you ever heard anybody use those terms? Unless you're deep into the tech field, probably not. So what does this mean for you? You're sitting there saying, well, I don't know what half of this stuff is. Kilobyte, I skipped over that one. Kilobyte instead of kilobyte. What this means is that as the drive manufacturers, they made the products exactly as advertised, but your computer, in many cases, especially if it's a Windows computer, is reading the drive in a factor of 1,024. So by the time you get all the way up to a terabyte, you are missing 99 billion bytes and change. So you're missing 99 and a half billion bytes. Almost 100 billion bytes of data are missing along this scale that your computer is expecting to see, but it's not seeing. when you factor that over the course of 4 terabytes, that adds up, and it keeps adding up, and as we start moving into petabytes, you're gonna see it even worse. We're not gonna move into petabytes for any time soon, I don't think. But the reality is that it's actually your software is reporting the data in bytes, but it's reporting data in. It's saying that you have 3.6 gigabytes because that's what you have in gigabytes. What's that word again? Yeah, gigabytes. Again, who came up with these names? So when your computer is sitting there saying, "Oh, I have 3.63 terabytes on this drive that's supposed to be 4 terabytes," and you're sitting there saying, "No, it's actually your software that's lying to you." The software should be saying that you have 3.63 Ti, lowercase I, B, which is tebibytes. Tebibytes? I forgot now. But anyways, the point being, it's not, tebibytes. There it is in my notes. That you have 3.63 tebibytes, not 3.63 terabytes, as the OS often reports. Now, some operating systems are different. I have a Mac here at home. I also have Windows. And Windows, you can plug the same drive into a Mac and a Windows, and it will report 2 different sizes because Mac actually reports them based on the actual spec of 1,000 is the gigabytes, and 1,024 is the gigabytes, whatever it is. So. And so the Mac will report that when you plug in a 4 terabyte hard drive that's advertised as 4 terabytes, it will say 4 terabytes in the operating system because that's how many you have. Now, when you go into the Windows properties and it'll show you the exact same number of bytes on both the Mac and the Windows, and when it strings it all the way out and gives you the trillions of bytes. But when it compresses it, it really should be showing you TIB, not capital T, capital B, because they're just not telling you the truth. This is the same across internal and external. It's just a matter of which operating system is going to show you the true information or the information they expect you to hear. Again, you've never seen any of this, and you've probably never even seen this term used if you're not deep into tech and really looked into this information yourself. So I just, again, wanted to clarify one little factor on there, that you're not missing anything. It's just a matter of counting. One company is going 1, 2, 3, 1,000, new. 1, 2, 3, 1,000, new. Another one's going 1, 2, 3, 1,021, 1,022, 1,024, new. And over time, those groups of 24 adds up, and as those groups of 24 continuously add up, you get continuously bigger discrepancies between what one pile has and the other pile has. And that's really all there is to it. They're not stealing data from you. They're not stealing your space. They just count differently. Hope this video cleared up something for you. Have a great day.